if you want to consult it afterwards or if you want to share this with one of your colleagues as well. All right, so we are with 27 people, so that's nice. I see a lot of familiar faces. I see also some new faces. I all hope you have experience with VRV Web Xpress because, of course, this is key. You are all key users of the software, and you are in fact indeed the first ones that will be able to work with this floor plan functionality. What is today's agenda? I will first start with an introduction. So why did we introduce 2D floor plan and what are the next steps? Then, of course, the basics or the reason why we have today's presentation, the training itself. And then at the end, I will give you the opportunity to make an exercise yourself. So then you can start playing around with the tool yourself, and I will be online and be there to help you whenever you have any issue. The presentation materials are on SharePoint. I put the link in the chat box as well, so there you will find the PowerPoint presentation that I will show you today, as well as the teaser movie and also some DXF and PDF files that you can use, for instance, for the exercise or whatever experiment you intend to do. Okay, so let's start with the introduction. So this is basically a slide that already exists for many years. It's actually our strategy related to VRV selection software. So the left side is the as-is situation. So here you can see that on one hand we have VRV Web Xpress, which is mainly focusing on the selection part. And on the other hand, we have our extensive VRV Pro selection software that is covering much more, because there you can do building design, you can do load calculations, you can even do energy simulations as well. So where do we want to evolve to? So on one hand, we want to extend the functionality of VRV Web Xpress a bit, also allowing to do some system layout. So that's why we decided to include 2D floor plan functionality into VRV Web Xpress. That does not mean that we will stop with VRV Pro. So until further notice, this tool will still remain to exist. But what we do expect is that many users that are currently using VRV Pro, just because of the fact that they can do the 2D floor plan over there, will move to VRV Web Xpress, because there you will see it will be much more easy to do, because in the end, yeah, VRV Web Xpress remains Express. So that's really our main purpose. Even when having that 2D floor plan functionality, you should be able to make selections in matters of minutes. Then on the other hand, but that will be part of another presentation, we are also looking into building plugins or integrations into third-party modeling software tools like, for instance, Revit. Developments are ongoing there as well, so we are building a proof of concept, and for sure in one of the coming months I will give more details on that part as well. But today's presentation will be on VRV Web Xpress, and in particular the new 2D floor plan functionality. All right, so let's move on to the next slide. This is briefly summarizing why we actually did this development. You can see there are a couple of advantages there. So first of all, accurate pipe design. If you would compare it in doing it manually, so if you have a floor plan and you have to manually measure all the dimensions with a ruler, yeah, then that's a cumbersome operation. More risk of mistakes as well. So by actually automating that functionality, so by actually foreseeing the possibility to import a 2D floor plan as an underlayer, you will be able to lay out your pipe design much more accurately. So the pipes will be on scale. Also interesting to know is that we also consider vertical pipe runs. Although we are working in 2D, this software also takes care of the vertical pipes, so the pipes going upwards in your building. So in this respect, it's even more powerful than VRV Pro, because in VRV Pro we don't do that. More accurate pipe design also means that the correct refrigerant charge calculation, or that this calculation will be much more accurate as well. You will be able to work faster. And an additional advantage, and I will also show that, is that you can easily check the surface of the smallest room to assure that you are not exceeding certain refrigerant limits. All right, so let's move on. What are our competitors doing? For sure, they also have 2D floor plan functionalities in their tools. So we have Panasonic, we have Toshiba, we have Samsung, we have LG. But all of these tools are Windows-based tools, and not all of them are that easy to use. In that respect, we are a bit different. So we are the first ones to have launched a 2D floor plan functionality in a web-based tool. And as mentioned before, our focus is still on Express. It's still our aim to make 2D floor plan selections in a very quick and easy way, but of course, maintaining a very high level of accuracy. And in the next half hour or hour or so, I hope you will be convinced of this fact. So what is next? So this timeline is showing what are our next steps. So today we are beginning of June. Last week I had my first key user training. So today this is the second one. It's the exact same one. So this is only towards affiliate key users. So users like you that are experienced users of VRV Web Xpress. So I gave to you already the floor plan functionality role. So as of today, you are able to make floor plan selections, but other people, for instance, are not able to do that. So we give you 2 months time to familiarize yourself with this functionality, and then to prepare yourself, of course, towards, let's say, end of July, where we really want to release this functionality to a broad audience. So in the 2 coming months, June, July, you will be using this tool. So my request to you is to start using 2D floor plan functionality on real life projects. But my suggestion is to start simple. So do not immediately start to create a 40-story building with this. Of course, it's possible, but I think you need to get familiar with it at start. So start simple. Start with a project of 1 or 2 outer units max. And my suggestion also is to create a schematic project, so a traditional way of selection in parallel. So, and as such, you will be sure that what you have selected is okay. And whenever you have an issue or a question, submit feedback to us. So the email address here at the bottom is well known to all of you. So submit it to software@daikin.zendesk.com. And we will pick it up as quickly as we can. So in the coming 2 months, we will further perform bug fixing and minor improvements based on your feedback. But next to that, we will also create some further promotional materials. So we will create a promotional movie. We will also create some more help materials, some training materials. And on top of that, we are also preparing a graphical user interface. You can see a sneak preview here on the right. We will change or review the user interface to make it a bit more contemporary, to have it a bit more sexy, let's say, using also new icons, new colors. But of course, we will keep on respecting the Daikin visual identity, that's for sure. Okay, then beginning of August, we will go live to a broad audience. So that's then up to you to actively promote this functionality in your countries. All right, so if there are any questions, then you can put them in the chat box. I will regularly check the chat box and try to answer your questions as much as I can. One more thing before we start with the training itself. So naturally, we will follow up the progress of floor plan projects. We can do that in Power BI. So there we will be able to compare the amount of schematics, so traditional selections compared to floor plan projects. As you can see, there are already 11 projects made since last week, because I had my first training last week. But of course, I do hope that in the coming months, this amount will go up fast. Okay, so let's move on to the training. So how do I see this? So first of all, I will give a bit of theory and then I will mix it a bit with a demo. So there are quite a lot of slides that I want to discuss with you, but don't worry, at the end, you will have time enough to use this functionality yourself and to get acquainted with it. So let's dive into it. The first thing when you go to VRV Express selection software that you will notice that when you create a new project, you will get a choice now. So you have either the choice to go for a schematic project, so that's the old way of doing, let's say, or you can opt for a floor plan project. Important to know is that there is no possibility to convert from a schematic to floor plan. So once you started in schematic, you have to stay in schematic. However, there is a possibility to export your indoor units and then to import them in a floor plan project. So I will show that later on. And then the opposite way, so there is also no possibility to convert from a floor plan project to a schematic project. But then again, why would you do that? Because everything that is in a schematic project is also in a floor plan project. So you will still see, for instance, the conceptual piping diagrams, the wiring diagrams as you used to. So there is actually no reason to revert back from floor plan to schematic. Within a project, you know that there can be several solutions. So you see here an example of a project with two solutions. In a project, a solution can be either schematic or floor plan, so it can be a mix of both. And a floor plan project will be indicated with this icon. So as such, you can recognize it more easily. Then another thing very important to know is that the undo redo functionality in the floor plan program is much more powerful. Maybe some of you remember in a traditional selection, when you do an undo, then you go back 45 seconds in time. But of course, in 45 seconds, a lot of steps can be done, a lot of actions you could have done. They are all undone with one click of that undo button. While now, with the floor plan functionality, an undo is really only going one step back. So if you move the pipe, and you undo, then that move of that pipe will be undone, and only that. If you change an indoor unit family name, if you change an outer unit, whatever individual action you have done, you can undo it step by step, and of course also redo it step by step. And that's very important, and you will for sure appreciate this more powerful undo redo functionality. Again, I will repeat myself. At this very moment, it's only available on floor plan projects. If you work in a schematic project, so the old way of doing it, there it's still the undo minus 45 seconds, but we are working on that. So it's just a matter of time where also on a schematic project, an undo redo will really be a step-by-step undo redo functionality. Okay, so when you start up a floor plan project, and don't worry, I will jump to the VRV Express very quickly to show it to you. When you start up a floor plan project, you will see two new tabs, the building tab and the floor plan tab. So let's start first with the building tab. In the building tab, you will see a list of floors of your building. By default, when you start a new project, there will be a roof and one floor. The roof you cannot delete. If you don't need a roof, you just ignore it. For instance, it could be that there are no outer units on that roof. Then you just don't use that roof at all. And then, of course, you have the possibility to add new floors. If you have a 20-story buildings, you will create 20 floors here as well. You can copy floors. And that's quite powerful because it will also copy the content of the floor, meaning if you already put some indoor units or pipes on that, then this will be copied as well. So if you have a very big apartment building where all of the floors are identical, then you only need to design one floor and then you copy the whole content to all the other floors. Of course, deleting a floor can be done as well, and moving up or down floors is very important. You have to put them in sequential order. The ground floor should be at the bottom, the roof at the top, because later on when you do shaft design, it's quite important that the software knows how the floors are positioned on top of each other. You see also two icons. When this is highlighted, it means that there is a 2D floor plan uploaded. And the second icon, when this is highlighted, and in this particular screenshot, none of the floors are highlighted, it means that it already contains some VRV elements like inner units or outer units. I think that's quite clear. When you choose a certain floor, for instance, let's select the ground floor, then you have the ability to upload a 2D drawing. And these are the formats that we support. You can upload a PDF file or a JPEG file or PNG, BMP, whatever. At this moment, we do not support DWG or DXF files. And yeah, maybe at first sight that would look strange because I think many of you will receive drawings coming from AutoCAD. But don't worry, from whatever drawing program, including AutoCAD, you have the possibility to export to PDF. So you can always request your consultant to deliver a PDF file. And that PDF file can be a single page PDF file. It can also be a multi-page PDF file where each page consists out of a floor of your building. Then you only need to upload that PDF file once, and then you can, by using the library, it's actually by clicking this link here, you can then define which of the pages belong to what floor. So you do not need to re-upload the PDF again and again. You only have to upload it once and then indicate which of the pages you want to use for what floor. And then very importantly, on each of the floors, you have to define a reference point. And to explain that better, I will go to this slide. The reference points ensures that the floors are perfectly aligned on top of each other. The software needs to know how they are positioned on top of each other, because if later on you do shaft design, it has to know where the shaft starts and where it ends in the other floor as well. And then a last thing, you also have to define a scale. And to do that, you have to move around this blue arrow, the scale arrow, as I call it. And then at the bottom right, you have to indicate what the length of that arrow is. So in this particular example, I have a room. I have defined that the scale arrow is 8 meters long. All right, then one more thing. For each of the floors, you can also define the heights. Of course, for a roof, there is no ceiling. There are not a lot of heights to be defined, except for one. You can indicate the pipe run height. So you can indicate how much above the pipe is running above the floor of that roof. In this particular case, I indicated that it's 0.2 meters or 20 centimeters on top of the floor or the bottom of that roof. For all other floors, there are, of course, much more heights to consider. You see here a drawing what they mean. You have to define the floor height, the room height, the pipe run height. And optionally, if there is a false ceiling, you can also indicate the false ceiling height or even a false floor height. In this example here, you see that the pipe run height is here. That's above the false ceiling. So the pipe is inside the false ceiling. But it could well be that your pipe run is, for instance, somewhere in the false floor. So I have seen buildings where they have put indoor units in a false floor, and then also the pipes are going inside the false floor. So you are fully flexible in defining the heights. They are done on floor level. If on a particular indoor unit there is a deviation, for instance, one indoor unit is in a mezzanine or is positioned a bit in a special way, then you can deviate the heights, or you can redefine the heights for that particular indoor unit. But these are actually, so the ones that you mentioned here are the default heights for the floor that you're working on. Enough talking. I will give a demo and show you the building tab. And then I think things will become a bit more clear. So I start up VRV Web Xpress, and as you can see, the first thing you notice, you have the choice between schematic and floor plan. Naturally, I will take a floor plan project, so it creates a new one now for me. Here it is. I need to give it a name. Let's call it Demo 3. And then I go to that new building tab. So in the building tab, you see that by default, there are already two floors, okay, the floor and the roof. On the roof, I can now upload an image if I want to use that roof. As mentioned before, if there is nothing to be done on that floor, you can just, on the roof, you can just ignore it. But in this particular case, I will position a outer unit on the roof. I will take a floor plan. In this particular example, it's a PNG file, but as mentioned, it can also be PDF. It's uploading that image now. Here it is. And now I will define the reference point. So I left click this symbol here, or this icon. I zoom in with the scroll mouse and I position it in the exact corner of that floor. Now the scale arrow there, I will zoom in to make sure it's connecting to the wall. And now I will extend that arrow and move it to there. And also here you can zoom in till pixel level and make sure that it's perfectly aligned with that wall. And do not forget, now I have defined the length of the scale arrow. Now I have to indicate how long that arrow is. In this particular case, it's 8 meters. So that's it for the roof. Now I will do the same for the floor. I can rename it. Let's call it ground floor, just to be more accurate. And now on that floor, I have to define the heights. So you could say, okay, the floor height is 4 meters. The room height is something like 3.7 meters. The pipe run height is a bit below, let's say at 3.3. And the false ceiling height, there is a false ceiling in this particular example, is 3. And there is no false floor. Voila. And of course, I still need to upload a background image. So I will again do the same action. I will now take this floor PNG file. And now also on this one, I will have to define the reference point. And also here, I have to define the scale. Voilà. And don't forget to mention the dimension of that arrow. So that's it, basically. So now the whole preparation work on the building tab has been done. If there are any questions on this point, post them in the chat box. If not, I will just go on with my presentation. So as mentioned, we have two new tabs. So the building tab, which we just discussed, and then we have the floor plan tab. So this is the one where you will be working the most, of course. This is where you will do the actual design. And the floor plan tab consists out of several panes. You have the Toolbox pane. I think you will recognize that one because it's a bit the similar way of working like in a schematic project. So you can drag and drop items from the toolbox to the working area, so to the floor plan where you will just drop them. On the right, you have the properties pane. This is also a bit similar to a schematic project. So for whatever object that you have selected on the working area, if it's now the floor itself or an outer unit or the inner unit, you will see all of its details here. And then you can, of course, change some settings. And you can change the inner unit family, the outer unit family, the design conditions, etc. Then there are three more panes here on the right. We have the search pane. You will really appreciate this one because it will allow you to search for particular indoor unit or outer unit models. Yeah, especially if you have a big project with, let's say, hundreds or thousands of indoor units, it can be a pain to find back a particular indoor unit model. Well, here the powerful search will come to the rescue. And then this one, the calculation results. This I will demonstrate a bit later on as well. So whenever you have done a design of a VRV, you have put indoor units, you have put an outer unit, you have drawn the piping, then you have to validate the project. It's not like in a schematic project that the validation is done automatically after every action you do. Here we deliberately did not do that. So you first do the design. The software will not check anything. It's only when you decide, okay, now I'm ready, now I want to check if everything is okay, that the validation will be done. And whenever there are errors, they will appear here. But also here, the software will guide you and will indicate, okay, the error is really on that particular render unit, or it's on that RefNet or whatever. So it will help you trying to solve all the errors or issues that you have. Also, this one I will explain a bit later. And then the indoor unit store, this is what we called the orphan box. So here, actually, you can import indoor units, for instance, coming from a schematic project, and then reuse them on a floor plan project. And then the pane here on the left bottom, this is the overview of the floors that you have in your project that you have created in the building tab, remember. And then the explanation tab is also a bit similar like in the schematic project, where you can see all the details of the device or element that you have selected on your working area. For instance, if you click on an outer unit, you will get information on the refrigerant charge, the pipe length rules that have been applied, etc. All right, so let's go through these panes one by one. So the first one, the toolbox pane, I think most of the icons you will recognize because they are similar to what you see in schematic, but you will notice that there are two new ones. We have the heat exchanger one and the shaft. The heat exchanger, you will need to drag and drop a condenser module for VRVI. So remember, a VRV outdoor for indoor consists out of a compressor module and a condenser module. So if you want to drag and drop the compressor module, you will use the outer unit icon. But of course, yeah, that condenser module also has to be put somewhere on the floor plan. Well, this is where you will use this icon for. It could be that we will rename it. Now it's yeah, too generic, heat exchanger. I think we will rename it to something more clear to really indicate it's belonging to VRVI. But in the end, the principle will be the same. And then another icon, and that one you will be using quite a lot, I think, is the shaft icon. So here you can then, or with this icon, you can then position shafts, one or more shafts on your working area. The working area yourself, so this is where you will see the 2D floor plan. There are a lot of icons there. I already mentioned this one, the validate icon. I will come back to that. You have the zoom in, zoom out, and zoom to fit buttons. You have the mirror button. This is to rotate a RefNet with 180 degrees. You have the measure area. I will also explain that. And then some actions, yeah, to cut, copy, or paste, delete objects. Then I think these ones are also quite familiar because you also see them in office applications like PowerPoint or Excel. To align icons, or to align, for instance, a bunch of indoor units. Import, exporting indoor units, I also mentioned. And this is also a nice one. With this slider, you can actually fade out or fade in the background image. And that can be handy because some of the 2D floor plans that you upload can be quite messy. They can be very crowded with a lot of lines. And that can be disturbing when you are drawing your VRV design. So you can fade out, you can even completely hide it if you like. But yeah, if you put it, for instance, to 10% in transparency, it will be much more clear what you are doing. All right, so let's discuss some of these icons in more detail. For instance, the measure area. If you click on that, you will see that a red rectangle is appearing, but you can move around the corners. You can change it in whatever shape you like. And then on the properties pane on the right, it will indicate what are the dimensions of that shape that you have put on the floor plan. It will not only show the lengths and the widths, but also the surface and the volume, and even the volume in the false ceiling, if you like, the net volume, the total volume. And this is handy information because you remember in VRV Web Xpress, we are checking the refrigerant limits, the toxicity and flammability limits, which you can see in the properties pane of an outer unit. Now you are able to verify if you are not exceeding that limit. So you will use this measure area on the smallest room of your building just to double check that you're not exceeding the limits that are indicated on the outer unit properties. Okay. I will also demonstrate that. And then, yeah, dragging and dropping indoor units, outdoor units, so VRV elements on the working area. So this is how they look like. I just took a couple of examples. If you drag and drop an indoor unit, then the indoor unit will look like that. Of course, this is an example of a cassette unit. You will see the 4 arrows indicating the air discharge directions. You will see a green circle here. So this is the rotate handle. You'll have to click this one to rotate the indoor unit. And then you have this here, this square green box. It could also be that it's not highlighted in green, that it's just an X. So this is your refrigerant connector. So this is where you have to draw the refrigerant piping to. On a multi-BS box, of course, there are several refrigerant connections. So this is a 6-port multi-BS box. You will also see when you hover above a refrigerant connector that a label will appear. So when up appears, it means that this is upstream towards the outer unit. And then on the other refrigerant connectors, you will see letters A, B, C, D. So these are then, of course, the various ports of a multi-BIOS box that are being visualized. RevNet is a bit the same. You also have the upstream connector and then the several let's say RevNet branches, which are labeled with letters as well. The Daikin air handling unit, whether if it's generic or not, an air handling unit, there we really went for a very generic representation because we don't have a clue where the refrigerant connections are. So you will see actually an unlimited, basically unlimited amount of connectors. So you can connect your refrigerant piping to each of those connectors. And of course, if you have a multi-circuit air handling unit, you will be able to connect to more than one of those connectors as well. But also this, I will explain a bit later. I think I have a dedicated slide on that as well. And then the compressor unit, I mentioned it before, we have a separate icon for that one. So when you drag and drop it, you will see that there are 2 connectors. So you have the heat exchanger connector going towards the condenser unit. And then the main is actually the connector going towards your indoor units. Okay, when you then click on the VRV elements, you will see on the right the property pane. For instance, this is an outer unit. I clicked on that. On the right side, you will see its property pane. And then you will see a visual representation of the vertical pipe height. So remember that on the building tab, on the roof, I said that the pipe run is going 20 centimeters above the floor of the roof. And then you will see that still there is an upward connector towards the refrigerant connector of that outer unit. There is a mistake in here. This is way too high. I know that. We are working on a fix. Actually, in this picture, the outer unit is put upside down. The connector is not on the top of the outer unit. It's somewhere here at the bottom of the outer unit. So the vertical pipe length will not be 80 centimeters. I think in reality, it's only 10 centimeters above the pipe run height, which is on its turn 20 centimeters above the floor of that roof. If I will take some other examples, like a floor standing indoor unit, when I click on that, you see its properties on the right. So in this particular example, it's obvious that that floor standing unit is on the floor. If the pipe run is in the false ceiling, it has to go down towards that floor standing unit, and the vertical pipe length, so this line here is in this particular case 3 meters. But you have the ability to change that. So if you have a particular indoor unit device that is deviating from the defaults of that floor, you can put other values on the properties of that indoor unit. Some other examples, a cassette unit is of course inside the false ceiling, touching the false ceiling. So there the vertical pipe run is much smaller than a floor standing because it's closer to the pipe run. And then the ceiling concealed, yeah, of course, this one is also somewhere inside the false ceiling as well. And then the last one, and there a point of attention, a wall-mounted indoor unit. So there you have to manually enter the height at this particular, at this very moment, I think we put 0 meters above the floor. So actually a wall-mounted unit would be positioned here. We will fix that. So for the time being, make sure that when you position a wall-mounted indoor unit to change the height to whatever it should be. But in the very near future, we will put a default of 2.5 meters or 2.3 meters just to assure that it's positioned correctly at start. All right. Maybe I will go back to the software and demonstrate whatever I have already explained till now. But I also check the chat box. I see a question from Darcia. How can we manage a floor that has some steps in it, meaning it's not completely flat? It sometimes happens in all buildings. Well, Darcia, this is what I just mentioned. So indeed, you can only define heights on floor level. And on the indoor units that are deviating from that, you will have to play around with this setting. So there is no other way. I know some of the buildings can be complicated with mezzanines or big halls that go across several floors. Well, in this particular example, you will have to be, let's say, a bit flexible and find your way in it. But for sure, I think most of the cases you will be able to tackle. Okay, let's move to the VRV Express software itself. So we've done the building tab. Let's move now to the floor plan tab. So you see the toolbox here on the left side. You see the properties pane on the right, the search, etc. You see the icons here. Be aware, my screen is a bit small. You have to move the handles a bit to the right to see, for instance, the transparency slider. Yeah, so on first sight, you could think it's not there. So you need to move around with those sliders. So all of these sliders you can move to the left or to the right or up or down. So if you're working quite a lot in the working area, you can actually completely hide them away as such, and then click here again to bring them back. Also, these properties panes, you can move up and down. For instance, if you don't need the indoor unit store, you can make it small as well, and then make sure that your property pane is as big as it can get. I see here a question from Alex. Can you put in the height difference between false ceiling and top of high wall mounted indoor unit? That's easier than the height of the bottom of the unit of the floor. Yeah, I will take that into consideration, Alex. I will have a look to this. I don't know if it's that easy to implement, but we'll have a look. All right, let's move on with the presentation. Yeah, the search tab. So that's one of those search panes. Sorry, the search pane is one of those panes on the right. It's quite powerful. You can search on a name of an indoor unit or an outdoor unit. So for instance, you can search for Laboratorio, but you can also look for a model name like FXZQ or RYYQ. And then you will get a result, a list with a couple of results. And when you click on one of them, on one item of that list, on one row, then the respective indoor unit or outdoor device will be highlighted in yellow. So as such, it will bring you very easily to the model that you want to look for. It will also jump immediately to that floor. For instance, you are working on the ground floor and suddenly you want to search for Laboratorio, which is somewhere on the second floor. When you double click Laboratorio in the result list, it will jump immediately to the second floor. So it will really bring you to the location where that device is being installed. So that's very handy, especially on larger projects with lots of indoor devices. Then the calculation results pane, also a pane on the right side. So remember, when you make a VRV design, it will not calculate automatically. You really have to press this validate button when you're finished. For instance, here I made a mini VRV design. The outer unit is here. I have a couple of ender units with a header. I'm finished with my work. Now I want to click this button, validate, and then you see in the calculation results, I get an error message. It says that I have somewhere a violation with my pipe rules. And then it could be that some further details can be found in the explanation tab as you used to do. So this is actually how you can solve problems. So again, if there are a lot of items in your calculation list, so a lot of errors, you can just double click and it will guide you to the particular ender unit where the problem is. And then you can try to fix them one by one. And then the other pane, another pane that is on the right side is the ender unit store pane or the orphan box. So this allows you to import an ender unit list, for instance, coming from a schematic project. Then they will be there in your ender unit store. And then from there, you can drag and drop them to the working space as well. Be aware, as long as there are ender units in your ender unit store, you will not be able to validate your project. So it will say, there are some ender units which are not connected to anything. I'm not able to validate. So make sure that when you're finished, so before doing the validation, that your ender unit store is empty. All right, that's the shaft designer. Let's first go back to VRV Express. I will now demonstrate the dragging and dropping of certain elements. So let's start with the roof. On the roof, I will put my outer unit. On the right, on the properties pane, I will indicate what type of outer unit is. I think that's quite clear to you. It's the similar way as you do it in a schematic project. You see the representation of an outer unit is just a square box. At this moment, the software does not know what model it is, so it will just put a generic dimension. You see the rotate handle here. You can rotate the outer unit, and if you hover around, you will find its refrigerant connection. All right, now move to the ground floor. I will put some ender units here. So I zoom in. I will say, okay, in this particular case, I will go for a round flow cassette. I will take a manual selection just to make my life easy in the demonstration. And I will select a 63 class model. So also here, the rotate handle, the refrigerant connector, you see also, but this is purely indicative. I did not mention that in the presentation. There is a water droplet. So this is actually the location of the drain pipe connection, but we are not doing anything with that. So it's not like this that you can draw drain pipes in the software, not as of today. Maybe that could be a future extension. So here it's just an indication. Yeah. All right, so now I can copy paste ender unit. So I can use either copy and paste here, copy, paste, and now I move it to here. But you can also use Control-C, Control-V. That also works. Yeah. Deleting is quite obvious as well. You just delete them. Just for my training example, I will make sure that the rotation is done in such way that the refrigerant connection is here at the bottom. And for this particular ender unit, I will make sure that the refrigerant connection is here on the right. Now I will copy that and paste to the other rooms. All right, so now I will take some other ender units. Let's take a floor standing model. Let me see, floor standing unit, and I will take a 50 class ender unit. You see it's quite big. So the dimensions are normally, yeah, they should be okay. They should be on scale, of course. So this nicely fits into this corridor, let's say. And then a last one that I will do is a wall-mounted Ender unit. So I will have to select wall-mounted here. Let me see if I find it. Need to make sure that I'm not taking the one that is on R32. Do I miss it somewhere? Fully flat, concealed ceiling. Oh yeah, okay, this is the wall mounted for 41080, so that's okay. I will rotate that Ender unit. So now you see why it's important that you can see the air discharge direction, because otherwise you would be able to position the Ender unit in the wrong direction, pointing towards the wall. Of course, that cannot be the plan. Okay, did I select an Ender unit? No, I still need to select the model as well. Let's also take 50. All right, so I have positioned Ender units, I have positioned outer units. The next step is, of course, to draw the piping. But before I can do that, I have to define a shaft that connects the ground floor with the roof. So I will drag and drop a shaft here. We'll move it here. I can change the dimensions of the shaft. And then I have to go to the properties pane on the right of that shaft and indicate in between which floor that shaft is going. So the lower floor is the ground floor and the upper floor is the roof. Voilà. So this is now done. And now I can start drawing the refrigerant piping. In the meantime, I see a question from Carmen Rodriguez Ortiz from Daikin Island. Can the software calculate the cooling load? No. This is really not the intention of VRV Express. Be aware, when you import 2D floor plans, you just import them as a picture. So the software does not recognize walls or doors or windows. So you still need to indicate the loads of each of the rooms or indoor units yourself, like you do in a schematic project. And then a question from Alex, what is the heat exchanger above shaft below RefNet header? So this is one I explained. So this is actually the condenser module of a VRVI. So if I have time later on, I can give a demonstration on that as well. But I think I also have a slide on that one. So we'll come back to this. All right, so I have now positioned the shaft. So what I will do now is, let's jump to the roof. I will connect the outer unit to the shaft. And by doing that, I have to draw refrigerant piping. So make sure that when you go to an element that you see the green square box, and then you can start drawing. You just draw the pipe and you make sure that it's connecting to a shaft. Also make sure that you see the green box. And then the pipe, your first pipe, has been drawn. We'll do the same on the ground floor, and we will start with the furthest Ender unit from the shaft. That's a hint that I can give. Always try to draw from the furthest Ender unit. Let's take this one. I draw a pipe. You can zoom in, of course. So using the scroll wheel of your mouse, you can zoom in. Using the left button of your mouse, you can drag the floor plan, and you can combine them. You can combine scroll wheel and dragging. All of that can be done. Now I'm focusing a bit on the drawing elements. For instance, this is a pipe segment. You see two end corners, which are highlighted with green squares, and you have a midpoint here or a center point. You can drag that one, and then it will create two pipe segments, like you can see here. If you want to undo that, of course, you can press the undo button or redo. You can also do it in another way. You can take this point and move it to this point and release it, and then it creates one straight line again. So these are handy tricks that will allow you to draw more efficiently. All right. Now I will take this Ender unit, and I will also, oh no, I will not do it like that. So I will escape. I will just first take the bottom one, because this is further away, and I will connect it to here. You see that the RefNet is being created automatically, but you see it's upside down. So I will I will click on the RefNet and will use this button to reposition it. And now I can make the connection more smoothly. Same for this end unit. You just draw a refrigerant pipe and you go towards this pipe and it automatically creates the RefNet. And the same for that one. You go here and you create a RefNet. Of course, I still need to do that for this end unit as well. Voila. You move it a bit to here. And this is also interesting to know. We always foreseen, and that's the same for end units, on a RefNet, we always foresee a default straight line of 50 centimeters. So there is always a straight pipe connection of 50 centimeters right after the connector of a RefNet. So either on this side or on this side, it always has to be straight towards the connector. So you're not able to bend this. Because this is common practice, you always have to respect a straight connection towards the connector of your RefNet. You can, of course, make it a bit smaller, but this is not recommended. So we always take a default of 50 centimeters. But if you have a very narrow space, I can imagine that maybe you want to make it a bit smaller as well. All right. So let's do like that and that. So yeah, actually, you have to familiarize yourself a bit with the drawing elements, but for sure, once you get the hang of it, it will go very fast. And then the last ender unit is here, so we'll also connect that one to the piping. So basically, you could say now I'm ready, but actually there is one more thing you need to do, and that's actually going to the shaft and click on this button, Open Shaft Designer, because there you have to indicate, and now you see actually an intersection of your building. You see the ground floor and the roof, and you know the shaft is going in between them. So you need to make sure that this connection is being made. So now it knows that these ender units of the ground floor are being connected to the outer unit of the roof. And now I'm ready. So if I now go to the roof and zoom in here, I can click on the validate button. So normally now you see an outer unit is being selected. And at this very moment, you will also see the dimensions, the diameters of the pipes appearing as labels on each of the pipe segments. In the calculation results, there might be errors or warnings. In this particular case, you see that I have a warning. It says the larger outflow connector connects to the smaller connection index. What does that mean? Well, just double click on it and it highlights the location where the problem is being caused. So let's zoom into that. There is something with this RefNet. And what is it? Well, on a RefNet, you always have to make sure that the biggest connection index is on the main connector and the smallest connection index is in your divergent connection. And here it's the opposite way. So you see, for instance, that on the divergent connector, we have 3 times, I think, a 63 class ender unit, while on the main connector, we only have once a 63. And this is a bit, I think this is the most difficult action you need to do in the floor plan, and we might consider to improve it a bit. So what you actually need to do, you need to swap the pipes. And how to do that? First of all, you need to disconnect the pipes. So I'll take that pipe and disconnect it, and then swap the connections. But of course, yeah, now you have a mess up of pipes. You need to rotate the RefNet with 180 degrees. And then you still are able to play around with it a bit to make sure that the pipe design is more neat. Well, so this is how to do it. So if I now validate again, that warning should disappear, and now I have a 100% validated project. Voila. All right, so so far the demo. So maybe indeed I need to demonstrate the search functionality as well. So to do that, I will just rename an ender unit. Let's call that the labo ender unit, and let's call this ender unit, for instance, my name. Then I think it's quite obvious if you now search on that, and I press enter, and you will see that it appears in the search results, and when I click on that, it will jump to that ender unit. So I think I swapped it. I didn't change the model. Anyway, so you see that it jumps immediately to that ender unit, and it highlights it in a flashy yellow color for you to easily find it back. However, you can also search on model name. So if I click FXFQ and then search, you will see that, yeah, when I click on the search, that you see that I have 4 results, and now I can click on each of them, and you will see the one that I have clicked will also have this green circle activated. So this is actually the model in question that you have just looked for. And then the ender unit store, maybe that's the last thing I will demonstrate before I go to the report. The ender unit store, so this is actually where you can import models from a CSV file. So you click on this button, you take a CSV file which you, for instance, took from a schematic project. Now this is being processed, and you see I have now a bunch of ender units in my ender unit store, which I can drag and drop wherever I like on the floor. Of course, I will delete them because otherwise I will get errors in my project when I validate. And another thing, as I mentioned before, the ender unit store has to be empty before you can validate. So actually I need to, and that's maybe also a bit annoying, we also have a fix on that. You need to drag them on the floor plan, group select them, and delete them as well. So now if I validate, normally there should still be no errors at all. So that's okay. All right, let's move back to the presentation. I think I explained all of the items that I have shown in the slides. Let's move to here. Yeah, the shaft designer I explained to you as well. So in this particular example, you see that on the ground floor, there are 2 pipe connectors coming in. So you will just have to connect them towards the outer unit in a similar way. To close the shaft designer, click on this button, and then you go back to the normal working area. That's also a bit for advanced users, but it's quite possible. So you are able to connect shafts to each other. So it could be, for instance, that a first shaft is going between the ground floor and the second floor, and that between the second floor and the roof there is another shaft. Well, then the piping from these ender units will go through shaft 1. Then shaft 1 is being connected to shaft 2, and then as such you can go to the outer unit. In order to design that, you always have to go or start with the shaft closest to the outer unit. If you do it the opposite way, it will not work. So you first have to define your connections in shaft number 2. Of course, yeah, before you go to the shaft designer, you need to make sure that you have a refrigerant pipe between the 2 shafts. You just draw a refrigerant pipe here. Then you go to shaft 2 designer, make your connections, and then you go to shaft 1 and make your connections. So that's the way to do it, and normally that will also always work. Then the mouse gesture. So what are the most frequently used actions? Actually, yeah, the scroll wheel is being used to zoom in and out. Right click is to drag and move the floor plan to the left or the right or upside down. Left click is to select an element. Shift button is to force drawing of horizontal or vertical lines. That does not always work, but can be helpful. Control right click is to multi-select elements. For instance, if you want to change the properties of 10 ender units at the same time, you can use control right click, or you just select entire area. And then scroll wheel plus right click is to zoom and dragging at the same time. Can be handy if, for instance, you want to draw a pipe between an outer unit and an ender unit that is very far away from each other. You cannot fit them on one screen. Then you can zoom in and drag the drawing at the same time. But I think most of these mouse gestures are quite obvious because they are also similar, like they are used in other programs. graphical programs or even PowerPoint. So I think once you know how to use them, it will be very convenient for you to use them. Yeah, this I also explained during the demo. So how to draw refrigerant piping, how to create bands, how to remove bands. So just put this midpoint and move it back to one of the endpoints, and then you get a straight line again. And as I mentioned, yeah, the pipe diameters will only appear after you have done a validation. So without validation, the software is not able to show you that yet. Automatic RefNet creation, so draw a refrigerant pipe from the inner unit to an already existing pipe on your plan, and it will create the RefNet automatically. And as I mentioned, on the inner unit or on the RefNet, there will always be a default straight line leaving the connector to assure that you're always perpendicular on the connection point, which is 50 centimeters, but which you could make smaller. You will not be able to change the direction, but you will be able to make it a bit smaller. All right, let's have a look in the chat box. If we have more outer units on the roof, the system can validate the service distance between the units. No, at this very moment, we do not check service or operation ranges between inner units or outer units. Actually, that might be an idea for the future, because actually all the information that you see on the screen, the pipe connector information, the location of the drain pipe, the location of the air discharge directions are coming from our BIM objects. And in our BIM objects, we also have normally the service and operation space defined. So it could be that in the future, we will also visualize that information on the screen. And as such, you will then be able to make sure that devices are not put too close to each other. But at this moment, it's not there yet. And then a question from Alex, does the system calculate the EN378? Well, I think I mentioned that in this slide, so let's scroll back a bit. You can do that by using this measuring area button. So you check, you put the square box, or it could be whatever shape, on the smallest room, and then in the properties pane, you can see what its dimensions are. And this you have to compare manually. So it's not an automatic check, but it's a check which is pretty close, let's say. It's very helpful. It can then be checked with the outer unit properties. So I don't know if you can read it, but here, for instance, the software says that the minimum area should be 21.6. But if I look to this smallest room, then the surface is only 3.1. So in this particular case, I would have an issue. Okay. However, yeah, I don't know if there is a door in between here. Maybe this room is part of the corridor, and in that case, you should not consider this as the smallest room. But it's there, the functionality is there, and you can do it in a very quick and easy way. I hope that gives an answer to your question, Alex. Laurent Villar, is there a shortcut to have vertical or horizontal pipe? Not sure what you mean with that. Maybe later on during the exercise, we can you can show it to me, and then we can have a discussion. All right, so let's scroll back to here. Yeah, flip RefNets. I also showed you that, so how you can swap the rotation of a RefNet. And then this I also demonstrate to you. So this is when you get this error here, the largest outflow connector connects to the smallest connection index. So in that case, you need to swap the pipes between the divergent and the straight end of the RefNet. You might need some practice there, because also the first times I had to do that, it's a bit cumbersome. But then again, if you have done it a couple of times, it will go for sure. Here, this is the slide on the VRV Alex. So this is indeed the icon that you will use to drag and drop the condenser unit. And then, of course, you will connect that condenser unit with the refrigerant pipe to the compressor unit. Of course, the software will check the limits all the pipe limits that are applicable on a VRVI. So also eventual limits between those two will be checked as well. And then, of course, the second pipe connector from the condenser unit, compressor unit will go towards the ender units. A VAM unit, also there a point of attention. Of course, a VAM unit does not have any refrigerant connection, so you do not need to draw any refrigerant pipe towards it. But on the other hand, you need to indicate to what outer unit it belongs in terms of communication. So when you click on a VAM unit, on the properties pane of that VAM unit, you have to say, okay, it belongs to this outer unit. So if you have 10 outer units in your system, you will see a list box with 10 outer units, out of which you have to choose one. And then, of course, it will become part of the wiring diagram of that particular inner unit. If you would forget that, don't worry, you will get an error message. So for sure, you will be confronted with this fact. And then another special device is the air handling unit. So here I took an example of a 2-circuit air handling unit. So it has 2 refrigerant circuits. So remember, an air handling unit has unlimited number of connectors. So you can draw the refrigerant pipe to each of those connectors if you like, because actually we have no clue where the connectors are on an air handling unit. You also have to define the dimension of the air handling unit manually. So whether it's a third-party air handling unit or whether that information is coming from the Astra software, you have to mention the dimensions, and then you can draw the refrigerant pipings as you used to do with other systems as well. All right, and then one more thing, the units tab, and actually this is also valid for the piping tab. These you know, because they're also there in a schematic project. These are also available on the floor plan project, but obviously you will not be able to change anything here. So these are only there for read-only purposes. So you will not be able to change in the piping diagram the sort order of ender units, which is of course obvious because you need to do that on the floor plan tab. But the schematic representation of your units or the tree structure of your systems, you will still be able to consult here. All right, I think I gave this demo already. So I showed you the floor plan tab, drag and drop ender units, drawing, validation, error notifications, and searching. Then there is only one thing left for me before you can start playing around with the tool yourself, and that's the report output. There are actually 3 report outputs, and for that one, maybe I will go again to the VRV Express itself. Right, so if I go to the reports tab, you will see here DXF, PDF, and of course still the Word report as we know that. Let's start with DXF. When I click on that, it will generate for each of the floors a DXF file, which you can re-import into AutoCAD. And that's interesting. So although the software starts with a PDF underlayer, you can export the piping diagram to DXF, which you can then submit to your consultant, which can then re-import it into his AutoCAD drawing. Okay, so I generated a zip file. So you see the zip file consists out of 2 files, the roof and the ground floor. When I double click on the ground floor, it will start my AutoCAD program. And that's a hint that I can give. I use LibreCAD. It's a freeware software tool that you can find on the internet. It's a very lightweighted tool, so especially for people that are not familiar with AutoCAD, it's an easy way to consult DXF files. And then you see indeed here the ground floor, the top view of the ground floor with the ender units, the shaft, and all the refrigerant piping. And these are layered, so you can, for instance, hide some layers. You can hide the header, you can hide the Daikin logo. And one thing that I want to mention, it's a bug, we're still working on that. You will notice that some of the ender units are too small. Let's see if I can zoom into that. So you see, for instance, this wall-mounted unit is 10 times too small. So it's because we have a wrong scale definition on that one. We are working on that, and that should be fixed very soon. And maybe I know that Darcia is joining as well from Italy. We also fixed as much as possible the issues that we had with ender units where, yeah, the DXF seemed to be a bit displaced or, yeah, not really on the correct location. That should be fixed as well. So that would be good news, I think, for all of you as well. All right, so let's close that. There are two other reports. Unfortunately, I'm not able to show them on production. They will be live tomorrow, however. So there is a possibility to also generate a PDF report. And also in the Word report, there will be more information. But I have some screenshots. And then again, as of tomorrow, it will be there. So don't worry. So the DXF I showed you. The Word report. So in the Word report, you will have, on top of what you already have in the Word report, the building details with all the vertical heights and the shaft definitions. So what is going in and what going out. On the schematic piping diagram, you will also see on each of the devices to what it belongs. So this is on the roof and this is on the ground floor. But in order to see that, you need to go to the report options of the Word report and enable these additional settings. So if you don't do that, you will not see anything extra. Then it will just be the Word report as you used to do. And then the last one, the PDF file, that's also an interesting one because there you will see the floor plan again. So the 2D floor plan drawings with the devices on it. And it will be layered, so you have the possibility to switch on or off certain layers. If you don't want to see indoor units or outer units or whatever, you will be able to hide them. And then also information, so the intersection view, let's say, of the shaft will be there as well in the PDF. I think the combination of PDF, Word, and DXF, I think you will have a wide choice of output formats which you can then share with your customers. All right, enough talking from my side. Let's see, are there any questions left? If not, then it's up to you. So I will put into the chat box the link to the SharePoint drive. If you go there, let's open it. You will see some examples. You can either go or to the training folder where you will see the roof and the floor PNG file that I used in my example. Or you can go to here, the floor plan examples, where you have some PDF files that you can play around with. And my request to you, I think in the coming 3/4 of an hour, so let's say till 12 o'clock, is to create your first roof or your first floor plan project yourself. So my request to you is try to build what I have shown in the demo. So create a 2-story building, import the 2D drawing, so the ground floor and the roof, the PNG files you can find on the SharePoint. You have to set the reference point, the scale, the room heights, place an outdoor unit on the roof, draw a shaft, draw the refrigerant pipes, etc. until where you're at the point that you can validate the project and generate the reports. So I will be standby. I will be there whenever you have a question. Put them in the chat box. We can even unmute you if you have a particular question. You can even share your screen if you're stuck somewhere. So take the benefit of me being here to help you. In the meantime, I see another question is coming in. Can we rotate the floor plan? No, you cannot rotate the floor plan. On the other hand, you're able to rotate the devices that are on the floor plan. So normally that should be okay. We had once the plan to do that, but I think it's not really a necessity. It should be okay. Okay, so up to you. In the meantime, I will play around with some other projects, show you some special devices as well along the way.